Digital Electronics tutorial for Dan on Tech. In this video, we'll start looking at Boolean algebra. Boolean algebra is a mathematical set of methods that we use for binary operations, the base 2 operations, and you can think of it similar to our algebra you may have learned in school. There are similar rules. There's a number of rules we're going to look at and how they work in it. It will probably take 3 to 5 videos to go through the Boolean algebra. I'm not sure how many yet we'll go through, how far we'll get in each video. With Boolean algebra, basically, we're going to create behaviors for the different types of logic gates we looked at, such as the AND gates and the OR gates, and we're going to look at a mathematics that allow us to describe those functions. So let's start with the AND gate, and if we start on that AND gate, what we'll do is, if you remember, with the AND gate, we had, say, an input A and a B, and our result was A and B, and if the truth table for that, we had A, B, and X. Remember, we would essentially fill the truth table by counting in binary for the 4 possible states or combinations we'd have. And with an AND, anytime there was a 0 in either of the inputs, whether it be both 0 or 0, 1, 1, 0, our output was a 0. Only when both inputs were 1 did we get an output of 1. Well, that behavior is very similar to multiplication. So when we're looking at it, we could say 0 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 0 is 0. And 1 times 1 is equal to 1. So we would have that multiplication. Well, the AND function would be A dot for AND B. That would be our Boolean expression for it, or we could write it without the dot. Just like with multiplication, you can write them without the dot or the X or whatever you're using for your multiply symbol. So we could write this A, B, and that would be read as A and B. Now, just like we have the AND logic, we also have OR. So if we have our OR gate with inputs A or B, our output X, the truth table for that, we had our A, B, and X. Once again, let's fill that. And with the OR, if both inputs are 0, we get a 0. If both input or either input is a 1, our output is a 1. So that is closer to, say, addition. So we would say 0, and we use the plus sign for that OR, for the OR. 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1. And 1 or 1 is 1. So that would be our truth table there. If we were doing straight addition, in decimal addition, 1 and 1, of course, would give us a 2. But when we do this in Boolean algebra, what we get is the 1. So that would be our second rule. So we would say A or B is equal to X would be our equation. A or B. And use the plus sign for OR. Now, the third gate that we've used is the inverter. We did the AND, the OR. We've got an inverter. And remember, the inverter had one input, and whatever the output was the opposite. So if input of A, output of X, and here we've got A and X. A only has two possible values, as 0 or 1, and with the inverter, remember, it was the opposite. So if the input was a 0, the output was a 1, and vice versa. And the way we express that, we would say that A naught, and we express the naught by putting a line over the top, is equal to X. So when we're dealing with the inverter or the naught function, so you'd read this as A naught is equal to X. So that's our inverter. Okay. Well, let's go ahead and stop here. We'll pick up in the next video. So thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss future videos. Please check out and subscribe to our other playlists on the Dan on Tech channel.